We've just been talking about how ocean water affects us by controlling our weather. This happens through changes in the temperatures at the surface of different parts of the ocean, affecting the amount of heat and water vapor that's loaded into air masses that move over land. But the ocean affects us in other ways as well. Water is always moving, and how ocean waters flow around the planet is important in ways that we only partially understand. Paying attention to the large-scale movement of water throughout the global ocean is nothing new. Ever since the days of the ancient seafarers, people have depended on powerful ocean currents for transportation, trade, and warfare. These currents behave in consistent, predictable ways as they have for centuries. That's why studying ocean currents has always been such an important part of successful shipping and naval operations. Throughout history, these currents have been important not only to the humans traveling over the ocean, but also to all of the other creatures moving around under the surface. These currents move nutrients, heat, salinity, density, and many other things around the ocean, causing reliable seasonal bursts of plant and animal population growth that form the basis of complex ocean food webs, including those that ensure our food supply. Just as a sea captain would use knowledge of ocean currents to make plans for ocean travel, thousands of marine species have evolved their life cycles around the timing of these physical, chemical, and biological events made possible by a stable ocean circulation. But climate change is changing ocean currents. Climate causes changes to both the temperature and the saltiness of water, and both of these affect its density. When bodies of water with different densities meet, such as when rivers flow into the sea or large amounts of ice freezes or melts, the denser water tends to sink, while the less dense water floats upward. As these waters exchange places, this creates flow. This flow is also influenced by surface winds, seafloor topography, and lots of other things. And when all of these things work together at large scales, they create currents. So think about the fact that the ocean is absorbing large amounts of heat. Meanwhile, a whole lot of ancient ice is melting, creating large influxes of cold, fresh, unsalty water. These changes are causing shifts in the way these global currents operate. Let's look at a couple of these currents and how they can change our lives even if we live far from any coast. This is the Gulf Stream current, which is a part of the Atlantic Meridional Overturning Circulation, or the AMOC, or AMOC system. It carries warm water close to the surface up the Atlantic coast from the tropics all the way to the Arctic Circle. You can see the impact of this warm water on the weather of the world. You might not have realized that the British Islands are so far north. Every part of Ireland, for example, is further north than any part of North Dakota. So why is Ireland so much warmer, wetter, and milder than North Dakota? Because of the warm, moist air blowing into the country from the Atlantic Ocean, brought up to from the tropics by the Gulf Stream current. If you like vacationing at the beach, you'll have noticed that you can swim in the warm water on the beaches of North Carolina in September, while at the same latitude on the California coast, the water is 20 degrees colder. Again, you can thank the Gulf Stream current. Many other named current systems operate around the world, providing conditions for local industries to flourish. Well, there's trouble in the water. Here sits Greenland, right near where the Gulf Stream current turns south. Greenland is the world's largest island, and it sits between the Atlantic Ocean and the Arctic Ocean. And Greenland has lots of ice. With the planet warming, Greenland's ice is melting fast, pouring fresh water into the ocean up north, meeting the Gulf Stream current. There's a scary amount of evidence that this is causing the Gulf Stream system to slow down. This weakness may be an important part of what is bringing such extreme weather to the Western Europe with droughts, heat waves, and catastrophic floods. Scientists have been worried about this slowing of the AMOC system and that it may lead to its eventual collapse, which would bring unfathomable changes to the weather in North America and Europe, as well as mind-boggling variety of impacts to ocean ecology and the industries depending on it. And more recent studies have shown that the slowing or collapse of the system may be coming more quickly than we thought. The thing is, this is the only planet Earth we ever have had to observe, so there's not a lot of certainty about exactly how some of these things are going to play out. Other mass movements of water are also slowing down, with lots of potential to cause problems. We've been talking about currents in terms of the movement of water at the surface of the ocean, but deeper waters also experience currents, and these are extremely important. The continental shelf off the coast of Antarctica has long been a source of a flow of cold water holding high amounts of dissolved oxygen, which flows into the depths of the ocean and spreads outward from there, fueling currents and bringing nutrients and oxygen to parts of the deep ocean far from the source. Accelerating melting of the Antarctic ice is making this water less saline and therefore less dense. Studies show that this change has already caused this deep ocean overturning current to slow by 30%. I really don't even want to think about how a lack of nutrient and oxygen supply, as well as a reduction in ocean-based global cooling, could affect life, not only in the global ocean, but on land as well.